So welcome to the first recording in MA2090 Precalculus. Chapter 1 is not really part of the course. Hopefully it's all review, but I'm going ahead and recording videos based off these slides so that they can help you out if you need to review this stuff. Maybe it's been a long time since you've taken a math class. Maybe you don't remember it so well. Whatever, that's fine. So here we go. Chapter 1 is all about learning how to graph points, functions, properties of graphs, stuff like that. So let's go ahead and take a look. So we're going to first learn the distance and midpoint formulas. Well, the objective is to learn how to use the distance and midpoint formulas, but first we should review how to plot points on the plane. Okay, so we start with a horizontal and a vertical axis. Okay, the horizontal axis, this one right here, we label as the x-axis. The vertical one is the y-axis. Where they intersect is called the origin, and it's usually just labeled with a big old letter O. Okay, this is called rectangular or Cartesian coordinate systems. If you go ahead and take a couple semesters of calculus, you'll learn about alternate coordinate systems, different ways of labeling points. This is really the only one we're going to use in this course, though, rectangular coordinate system. Okay. You've got your x-axis, which is your horizontal. You've got your y-axis, which is your vertical. Between them, you get the xy plane with coordinate axes. Points on the plane can be labeled using an ordered pair, two numbers, and the first one is always the x-coordinate, and the second one is always the y-coordinate. Okay, so the ordered pair is called the coordinates of the point. So let's take a look at a couple of these. So here in the upper right, we have the point labeled 3, 2. The first coordinate is 3, that's our x-coordinate, and it says, starting from the origin, move horizontally by 3 units. Okay, so 1, 2, 3, and then we're here. The second number tells me y is 2, so now move up 2 units, and there we go. So let's take a look at this point right here. Now the only difference, x is still 3, so from the origin we go 3 units to the right, and there we go. But now y is -2, and that tells me just move down by 2 units rather than up. So similarly over here, instead of moving right, since x is negative, x, remember, is always the first number. We move left by 3 units. The y-coordinate is positive, so I go up. And here, both of them are negative, so I go left and down, and that's how we end up there. The first number is called the x-coordinate. The second number is called the y-coordinate. They have these alternate terms here, abscissa for the x-coordinate and ordinate of a point for the y-coordinate, and I've never heard anyone use them. Everyone just calls them the x and y coordinates, so don't worry about these other words. Okay. We do, however, divide the plane into quadrants. So if I move right and up, then I'm generally going somewhere in this direction, and that's the first quadrant. If, however, I'm moving left and up, well, then I'm doing something like this, and that's the second quadrant, quadrant 2. If I'm moving left and down, then I'm doing something kind of like this. That's the third quadrant. And similarly, if you're moving right and down, then you're over here, and that's quadrant 4. And the way to remember the order is start in the positive x direction, just going straight right, and then rotate counterclockwise. And you go through 1, 2, 3, and 4. This notion of starting in the positive x direction, in the right direction, and then rotating counterclockwise is something we're going to do a fair amount later. Start from going straight to the right, rotate counterclockwise, and there's your order, quadrant 1, 2, 3, 4. Okay, let's take a look at the distance formula. So we want to find the distance between 0, 2, and 4, 5. So we plot the points by saying, okay, 0, so don't move from the origin. 2, go 2 units up. On the other hand, our other point is 4, 5, so go 4 units over and then 5 units up, and then here's that point. So we draw this line segment between them and label it with a D. Can we find the length? Well, we've got this point here at 0, 2, and this point here at 4, 5. Now, if I were to just draw this horizontal line, the horizontal line going through this point here, and the vertical line going through this point here. Okay. Now a horizontal line is all points at a given height. So every point on this line has the same height, but this point has height too. So all the points on the horizontal line have height too, which means this point here also has height too. A vertical line, everything on this vertical line is the same horizontal component. Okay, it does change its vertical component, but it doesn't move left or right. It just goes up and down. So every point on the vertical line has the same x-coordinate. This point has coordinate x-coordinate 4, therefore this point also has x-coordinate 4. So now this point, I know its x and its y coordinate. It's 4, 2. Okay. What are the lengths of these sides? So this just goes from right to left. Notice that the y coordinate is not changing. It's 2 for both. So it's just moving horizontally, going from 0 to 4, which is 4 units long. Now on the right-hand side, our x-coordinate isn't changing. It's only going up and down, and it goes from 2 to 5. What's the distance from 2 to 5? 3. Okay. But now I've got a right triangle because I'm connecting a horizontal and vertical line. So I know that if I square this side, 4 squared, and I add 3 squared, I end up with d squared, the unknown length. Okay, 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. So if d squared is 25, d is the square root of 25, which is 5. Okay, so there's our distance formula. If you have a point P1 and you have a point P2, so this is x1, y1, and this is x2, y2, you can make a horizontal or vertical line connecting out of any of the 2 points you want. It doesn't really matter which way you do it, but I want to determine the length of the segment connecting them together. Okay. So what I'm going to do is I'm going to make a triangle, and you can do either this one over here or you can do this one over here. Whoops, somehow that went away. And it doesn't really matter. I'm on the left right now, so we'll just do this. What's the length of this right here? Well, it goes from this y coordinate to that one. So this is of length y2 minus y1. What's this horizontal? Well, it goes from x1 to x2, so it's of length x2 minus x1. And now my unknown is the hypotenuse, so I end up with d squared equals x2 minus x1 squared plus y2 minus y1 squared. And if I take the square root of that, we end up with exactly the distance formula here. So can we use the distance formula to find the distance between the points -4, 5 and 1, 3? Well, all we have to do is use the distance formula. You don't even have to draw the picture once you have the formula. Okay, so our x-coordinates are -4 and 1, so we do a 1 minus -4, and our y-coordinates are 5 and 3, so 3 minus 5. A lot of people ask, what if I put them in the other order? Well, it doesn't really matter. Okay, so we'll finish it with this order. 1 minus -4 is 5, 3 minus 5 is -2. 5 squared is 25, and -2 squared is 4. What if we did it in the other order? Will we get the same thing? Well, we'd have -4 minus 1 squared plus 5 minus 3 squared. And what's -4 minus 1? It's -5. And what's 5 minus 3? It's 2. So notice these numbers are technically different from these ones, but when I square them, the 5 and the -5 are both going to square to 25, and the 2 and the -2 are both going to square to 4. So at the end of the day, it doesn't matter what order you put them in. You'll end up with root 29 regardless. Okay. So here's a geometry problem. It's going to involve pretty much everything we've done so far. I have 3 points, -3, 1, -3, 4, 4, 1. Plot them all and make a triangle. Find the length of each side, determine whether or not it is a right triangle, and then find the area. So plotting the points, -3, 4, move 3 left and 4 up, -3, 1, 3 left and 1 up, 4, 1, 4 right and 1 up. Great. Find the length of each side. Okay, so we're just going to use the distance formula. This is the distance formula connecting the point, connecting the point -3, whoops, click on the wrong thing, -3, comma, 4, to the point -3, comma, 1. So I take the the difference of the x's, so -3 minus -3 squared, plus the difference between the y's, 4 minus 1. First term gives me a 0, second term gives me a 9, after squaring, of course. 4 minus 1 is 3, which squares to 9. Root 9 is 3. So our triangle looked kind of like this. Here are -3, 1. Here was -3, 4. And so we've just determined that this length here is 3. Okay, our other point, pardon me, was 4, 1, so that's over here. So if we try to connect these 2 points using this diagonal line, 4 minus -3, that's the difference in the x coordinates, 4, -3. Difference in the y's is 1 and 4. Okay, 4 minus -3 is 7, 1 minus 4 is -3. Square those and you get 49 and 9 for root 58. And then the last side, that's just going to be down here on the bottom. And we're just doing the same thing. Take the difference of the x coordinates. The x coordinates are 4 and -3, and the y coordinates are 1 and 1. 4 minus -3 is 7, which squares to 49. 1 minus 1 is 0, which squares to 0. Root 49 is 7. So here we have a root 58, and down here it's just 7. Okay. So just to draw again, we have a 7, we have a 3, we have a root 58. The next part asks us, is this a right triangle? All we have to check is if I take the two shorter lengths, the 3 and the 7, and I square them and add them up, do I get the same thing as if I had just squared the longer one? Everyone knows if you have a right triangle, then a squared plus b squared equals c squared. But the converse is also true. If you have a triangle, and I just label sides a, b, and c, if a squared plus b squared happens to equal c squared, well then yes, I have a right triangle and the hypotenuse is c. So in our triangle we had a 3 and a 7, those were our short lengths. And our long length was root 58. And what's root 58 squared? Well, it's just 58. And observe, 3 squared plus 7 squared really is the square root of 58 squared. It's 58. So yes, this is a right triangle because the square of two sides added together was the square of the third. Notice not every triangle will solve this. I mean, if I just draw an equilateral triangle, every side is of length 1. Is 1 squared plus 1 squared equal to 1 squared? No, that's not a right triangle. But sometimes it does work out. In a triangle it did, therefore it is a right triangle. And then we were asked, can we find its area? And I'm just going to copy the picture. Oops, I apologize for my bad drawing. Forget all that. Here is our triangle. We had a 3, we had a 7, we had a square root of 58, and we determined it was a right triangle with root 58 as the hypotenuse, so it goes across from the right angle. Well, what's the area of a triangle? It's 1/2 base times height. We've got a right triangle, so let's just go ahead and use base and height as 3 and 7. 1/2 3 times 7 is 21/2 square units. Square inches, square centimeters, whatever wasn't given to us, it doesn't really matter. Okay, that was the distance formula. Now let's check the midpoint formula. Okay, so the midpoint is if I have a point and a line, and one end is given by P1 and one end is given by P2, can I find a point on the line so that this distance and this distance are exactly equal? It's exactly halfway down the line. And the formula is actually given to us. It's just average of the x coordinates and average of the y coordinates. Okay. So find the midpoint of a line segment from this point to that point, P1 to P2, plot them, plot the midpoint. Well, we're going to find the midpoint before we even plot anything because it's just a computation. The x coordinates are -4 and 4. The y coordinates are 4 and 2. So if I average the x coordinates, I do -4 plus 4 over 2, and that's 0. And if I average the y coordinates, I do 4 plus 2 over 2, and that's 3. So the midpoint must be 0, 3. And now let's go ahead and plot them. The point -4, 4, 4 left and 4 up. The point 4, 2, 4 right and 2 up. 0, 3, don't move left or right, just go 3 up, and it's right there at the middle of that line segment. Okay, so that's the end of this section. Hopefully things like midpoints and distance formulas you kind of remember. I mean, maybe it's been a long time and you kind of forget how to do it. That's fine, as long as the general notion rings a bell. And if it doesn't, just practice some of the problems from this section in the book until you get the hang of finding the distance between 2 points, because we're going to use that a fair amount. Finding the midpoint of a segment, we won't use as much, but it's a much simpler procedure, so go ahead and get that down as well.